Hi, my name is Mr. Choni and welcome to my study room. If today is your first time of coming here, then I strongly encourage you to subscribe to my channel for more videos. Today's study is on how to determine if a quadratic equation has repeated or equal roots. Let's go straight to the lesson. Thank you. If the roots of a quadratic equation are equal, then it means that the discriminant will be equal to 0. So let me just write that. Alright, so for repeated or equal real root, b squared minus 4ac, which is the same as the discriminant, will be equal to 0. Or, in other words, we move this one to the right hand side. So b squared will be equal to 4ac. So in the graph where our a is greater than 0, that means the graph will look like U or dome shape. We'll sketch our graph like this. This is our x-axis, this is our y-axis. For repeated roots, our curve will only touch the x-axis. So this will be our root. The root will only be 1. So with all the examples we are going to use for which the equation will have repeated root, if you should sketch it on a graph sheet, it will not cut the x-axis twice. It will only touch it and go back. So you can see that in some of the questions, they will tell you to find a missing value if the x-axis is a tangent to the graph or the x-axis is the tangent to the curve. You get that? It means that indirectly they are telling you that if the equation has repeated root, because with repeated root it will not cut, it will only touch it. Alright, then for the second scenario B, where a is less than 0, here the graph will look like n. It will be n shape. So let's sketch x and y. Then let's say our graph looks like this. It will only touch the x-axis. The highest point or the maximum point of the graph will only be on the x-axis and not cut it. With all equations that have repeated roots, when you sketch the graph, the curve will only touch the x-axis. It will not cut it twice. Technically, practically, when you use the calculator to solve, there will be only one answer. So some books will tell you that it has only one solution. But then it is only that it is a repeated number. So the calculator doesn't want to repeat. So it will show only one answer, and that is it. But it's actually repeated roots. Let's take some examples now. If 3x squared minus 4x plus k equals 0 has equal roots, find the value of k. So we have established the condition for an equation to have equal root already. That's what we have here. That if the equation has equal root, the discriminant should be equal to 0. So that is just what we are going to use. What we are going to tell ourselves what the a is. Our a is 3, the coefficient of x squared. Our b is -4, and our c is what? K, the one without any x attached to it. So now we are going to tell ourselves that for equal roots, the discriminant, which is b squared minus 4ac, should be equal to 0. That means we are going to tell ourselves that -4 squared minus 4a is 3. Then our c is k should be equal to 0. -4 squared is 16 minus 12k is equal to 0. We are looking for the value of k. So we group like terms. -12k will be equal to -16. We divide both sides by -12 since we want the k to stand alone. This one goes with this one goes with it. So our k will be equal to, this one go 4 goes here 4 times, goes here 3 times. So 4/3. It means that when we fix this our 4/3 in place of k here, the discriminant will be equal to 0, or it will have repeated root. We can also verify with the calculator. We go to mode, where we go to equation, which is 5, then quadratic equation, which is 3. All right, so our a is 3, our b is -4, and our c is now 4/3, just as you wanted. Yeah. So our x is 2/3, and it's only one answer. Like I told you, the calculator will give you only one. So we don't have x1 and x2 like in the other cases. So this shows that since it has only one solution, it means that this is a repeated solution. Let's take another example. In the second example, if kx squared plus 2x plus k equals -kx have equal roots, find the values of k. Here we have to even rearrange this one so that we'll have x squared terms, x term, and then a term that has no x in it. Let me just rewrite that quickly. We can move this one to have like terms. So we are going to have kx squared plus 2x plus kx plus k equals 0. That is not all. You have to factor the x out. So this will give us k squared, kx squared plus 2 plus kx plus k equals 0. Yeah. Now we can have our a, b, and c now. So our a is going to be the coefficient of x squared, which is k. Our b is the coefficient of x, which is 2 plus k. And our c is the one that I have x in it, which is k. All right. And then we know that for equal roots, b squared minus 4ac should be equal to 0. Is that not so? Alright. So now let's fix that into it. RB is 2 plus K whole squared minus 4. Our A is K. And then our C2 is K. And this should give us 0 if the equation has equal roots. So by expansion, using binomial expansion, this is going to give us 4 plus 4K plus K squared minus 4K squared equal to 0. Then we group like terms. This and this are like terms, so you're going to have 4 plus 4K minus 3K squared equal to 0. Rearranging, you're going to have negative 3K squared plus 4K plus 4 equal to 0. Then dividing through by negative 1, you are going to have 3K squared minus 4K minus 4 equal to 0. Depending on whichever method you want to use to solve, I would like to use the factorization. So I have my K here and my K here equal to 0. So now 8 times 3 is 3 times negative 4 will give us negative 12. I'm looking for 2 factors of negative 12 so that when I add them, the result will be negative 4. So that will be negative 6 and positive 2. Negative 6 and positive 2. And this one, anybody who has issue with this can go back to my video on solving quadratic equation using the factorization method, and I took my time to explain each of them very well. That is why I seem to be going a little faster here. So we have minus 6 then plus 2, because 2 times negative 6 will give us negative 12. 2 plus negative 6 will give us negative 4. But remember, in that video we said whenever the A is not 1, we divide through both sides by the A. So divided by 3 divided by 3. Using the now factor analogy, is either K minus 2, because 6 divided by 3 is 2, is equal to 0, or K plus 2 over 3 equal to 0. That means our K will be equal to 2 or negative 2 over 3. So this means that this equation in the question will have equal roots if K equals 2 or K equals negative 2 over 3. This is what I mean. This equation here will have equal roots if K equals 2 or K equals negative 2 over 3. Then again, you can fix these two in place of the K in the original question and solve to see whether you will not have repeated roots. That is how it works. And this is where we end today's lesson. Thank you. This is the end of today's lesson, and I want to thank you so much for making time with me. Don't forget to subscribe to this channel for more videos. Till we meet again in my study room. Bye bye.